Hello grade 11s, welcome to 2.3 Angle Properties in Triangles. What we're going to do right now is we're going to prove that a triangle's angles are equal to 180 degrees. This is similar to the activity you just did. You just demonstrated with one example, but now we're going to prove in the general case. So we're going to do statements and justifications. What I first want to do is I'm going to draw a line parallel to CB. I'm going to call that D and E. I'm going to make the markings to show that that's parallel. Next I'm going to do, just so you can see things a little better, is I'm going to extend these lines. A lot of times when you're doing proofs, simply extending lines makes some things pretty apparent. So the first thing that I can see is that angle DAC right here is congruent to angle ACB. And the reason for that is because those guys are alternate interior angles. Okay, using the same logic, we can see that angle AEB is congruent to angle CBA. Okay, I have to get these right. Sometimes I write them wrong. Angle EAB is congruent to angle CBA. And also by alternate interior angles. What we're going to do next is we're going to look at a straight line here, and we're going to pull some information from that straight line. So the straight line I want you to look at is line DE. So line DE is actually a sum of a bunch of angles. We add up angle DAC, okay? We add angle CAB, and finally, we add up EAB. When we add these all up together, because they are a straight line, we get 180 degrees. Okay, so this entire statement we can say because they form a straight line, or form line DE. Okay, but we saw that angle DAC was equal to angle ACB, so we can just substitute angle ACB, okay, because we saw that these guys were equal. We just substituted. Angle CAB, we don't have any relationship that we know about that one yet. Now, what was angle EAB equal to? It was equal to CBA. So we just substituted. We used things that were equal. That's called the transitive property. Is that the transitive property? A equals B. No, that's not transitive at all. Sorry, guys. That's just substitution. I'm getting excited. Substitution. Now let's look at these angles I'm talking about. I said angle ACB. I'm going to mark these ones. I'm running low on colors here. I'm going to mark these ones with, see if I can do purple. Okay, so I have angle ACB. That's this angle right here. And I have angle CAB. That's this angle right here. And I have angle CBA. That's right here. So I said that the sums of these three angles is equal to 180. I proved that the sum of the angles of a triangle is 180 degrees. And this is an important proof that may come up again. I have proven that the sum of these angles is 180. Now that I've shown this, now that I've proved this, we can use this fact from every proof from now on. Since we have proven it, we can, every problem we come up to, we can use this fact to solve it. And we're going to look at a problem right now where someone used this fact. So we have a triangle. MTH, this angle right here is an exterior angle. It's called the exterior because it's on the outside of the triangle. Determine the measurements of the unknown angles. And this is what Serge did. He said MTA plus MTH equals 180. He said, look, this forms a straight line. That equals 180. Well, if that equals 180, he subtracted. He saw that that small part, that MTA, must be 25. Okay? Then he knows that all of the angles in the triangle, 25 plus 40 plus something, has to equal 180. He substituted and found that that angle was 115 degrees. Okay? So we're using the fact that supplementary forms a line and the fact that the interior angles of a triangle add up to 180, which we proved. In this next example, we're asked a question. So we found all the angles given this triangle, but it says if you are given only one interior angle and one exterior angle, can you always determine the other angles? Explain using diagrams. Well, we found in this case, yes, we could. And so I want to talk about the relationship between this. So this angle is not right beside that 155, or in other words, it's not adjacent. So I want to talk about if it was adjacent. So we have some triangle, and all we know is that this, let's say, is 155. Let's do better numbers. We say that this angle is 120, and I also told you that this angle here was 60. Is there any way that I could figure out these two angles? There is no way because we have no relationships that we can pull for. So this works when it's we call this a non-adjacent angle. But when you are given an adjacent exterior angle, adjacent is a fancy word for right beside, then you can't figure it out. It's impossible to figure it out. They go through that example here in more elegant words than I use. If you're given an exterior angle and one non-adjacent, then you can determine. So this is in this ABC. We have a angle, and this is its non-adjacent one. Okay? However, if the interior angle you are given is adjacent, so here's our interior angle adjacent to our exterior angle, then you cannot determine the other angles. For example, in PQR, neither the non-adjacent interior angles are known, so neither this one nor this one are known. So there's not enough information to determine the unknown interior angles. So we have to be very careful when we use this property that we are given a non-adjacent angle. So we're going to try and figure out this relationship. So we want to determine the relationships between an exterior angle and its non-adjacent interior angles. So non-adjacent means two angles of the triangle that do not have the same vertex. So the non-adjacent angles to angle D are angle A and B. They do not share a vertex with angle D. Okay, so a couple things that we're going to notice. We're going to write down here. We know that angle D plus angle C are equal to 180. Why? Because they're supplementary. So in other words, I could say that angle D is equal to 180 degrees minus angle C. That was just by rearranging. The other thing that we learned this lesson is that angle A plus angle B plus angle C, the interior angles of a triangle, add up to 180 degrees. Rearranging, I can say angle A plus angle B is equal to 180 degrees minus angle C. Wait a second. We've seen this before. 180 degrees minus C, 180 degrees minus C. So in other words, just by substitution, we can say angle D is equal to angle A plus angle B. And now that's using the transitive property. I've been eager to use that all lesson. If the transitive, again, is if A equals B and if B equals C, then A equals C. So I've said, oh look, we have D equal to 180 minus C, and we have A plus B also equal to 180 minus C. Well, then these two things must be equal. So what does this mean? This means that for every exterior angle, it is equal to the sum of the non-adjacent interior angles. So this is powerful. This is something we can use now. So we're going to use some of these properties that we learned to solve this problem. We want to determine the measure of NMO. So determine the measure of this guy. Determine the measure of MNO. Oh, these are such tough. Determine the measure of that guy. And QMO. Where is QMO? The measurement of this guy right here. Okay. So one of the first things to note is we got some parallel lines, right? So we have parallel lines and we have a bunch of transversals as well. The first transversal I want to kind of point your eyes at is RM, this transversal right here. And what I want you to see is what angle 67 would be equal to. So 67 degrees would be equal to this measurement here because of alternate interior angles. So 67 is going to be equal to angle MNO plus, so that's this guy, plus 20 degrees. So we can solve that angle MNO is equal to, we're going to subtract 20 for both sides, to 47 degrees. Okay, so just erasing some of that here so we can see our diagram a little better. Now we have seen that this is 47 degrees. We got a triangle there and we know two of its angles, so we can find its last angle. Okay, so we know that angle NMO, wait a second, NMO. Sorry, I originally found this one. Those letters are really, really close together. Now I'm finding this guy. NMO plus 39 degrees plus 47 degrees is equal to the sum of the angles of a triangle are 180 degrees. Substituting from both sides, you get angle NMO is equal to 180 minus 47 minus 39 is 94. Okay, so we found this guy and this guy. We'll write that in our diagram. We have 94. How can we, there's a couple ways we could do this last one. 94 degrees. Knowing that we have some parallel lines going on in a transversal. Well, what could you tell me about this angle here and this entire angle there? Those are alternate interior angles. So they're going to be equal. So we could say, actually I'm going to erase so that we have more space. So we can still see our diagram here. We could say that 94 degrees plus angle QMO, this one right here, plus angle QMO is equal to this guy. Well, how do I know that guy? I can say that there's an entire 180 degrees minus this part. So is equal to 180 minus 47 plus 20. Okay, so that is so I have 94 degrees plus angle QM0 is equal to 180 minus 67 should be 113. You know, we could have done this easier just by that 67 degrees was there by 180. That would have been much easier than what I did. And this happens oftentimes in triangles. There's sometimes more eloquent ways. Okay, so angle QMO is equal to 113 minus 94, which is 19 degrees. What we've learned is you can prove properties of angles and triangles using other properties that have already been proven. So the first thing that we proved is that in any triangle, the sum of the measures of the interior angles is proven to be 180. You should know that proof. And we've also proved that the measure of any exterior angle of a triangle is equal to the sum of the measurement of the two non-adjacent. So in other words, this guy right here is equal to this angle plus that angle. That is what we have proven. The questions I'd like you to do are number 3, 5, 8, 9, 13, 14, and 17. Just a quick reminder, if you have a triangle and there's two ticks here, that means that those two sides are the same. In other words, that is an isosceles triangle. The relationships with an isosceles triangle is that the opposite angles opposite to the sides are equal. So those angles would be equal. Another thing is if I have an isosceles triangle with a triangle with three equal sides, that's called an equilateral triangle. And it also means that all three angles are the same. So there's some relationship you can find. You can actually determine the angles without even giving any measurements there. Okay, good luck.